Alright, on this problem, you're gonna use the acceleration due to gravity is 32 feet per second each second, because this problem is in feet. If I'd been doing meters, I would use this one. I'm gonna fire this object at 50 feet per second at a 40-degree angle off a 40-foot cliff. And we're gonna get the final velocity when it hits the ground, and how far it travels across here. So, first thing we're going to do here is change this into its components. And this is just solving a right triangle. You got 50 sine of 40 is the vertical component. The horizontal component is 50 cosine 40. And then once we get those, we need to find the time it takes to get from here to here, so we can see, figure out how fast it's going when it falls down here. We need this distance here, this time it takes to do this. So to do that, we take this, the vertical component was 32 feet per second. You divide that by the acceleration, and what you get is this, you get 1 second. I did it right here. So it took 1 second to go from here to here. And then we need to find that distance. And since it, right here it was going 32 feet per second, up here it's going 0 feet per second. The average of those two is 16 feet per second. For 1 second makes this 16 feet here. You add that to the 40 feet, and you get this total distance here. Now, your vertical and horizontal speed are independent of one another. That's an important concept to be able to do these problems. The vertical component does not affect the horizontal component. And so, if I know how long it takes something to fall from here, it's the same as how long it takes this to get here. And so to figure that, you use the acceleration and this distance. You take the distance divided by the acceleration, and the distance is 16 feet. I mean, the distance is 56 feet, and the formula for this is 16t squared equal the distance. So, I was saying that wrong. The distance here is 56 feet. Use this formula here to get that time. And once you get the time, you can multiply it by 32 to get the speed. So the time is 1.87 seconds to get from here to here. You multiply that by 32, and you get the final velocity is 59.84 feet per second downward. The horizontal velocity is the same as the horizontal component here. It didn't change. The horizontal component is right here. And then you solve this right triangle for the final velocity, which works out to be this. And now I need the total distance across here, and to get that, I add these two times, this time and that time. That's 2.87 seconds times the horizontal component, which is 38.3 feet per second. And that'll give you the whole distance across here. Let's see what that is. 38.3 times 2.87. No.
Oh, okay.
109.92. 109.92
You just.
feet is the distance from the bottom of the cliff to where it hit out here.